Welcome to this video tutorial, one of many in a series designed to get you up and running with Leapfrog. This video is part 1 of 2 discussing importing and viewing 2D surface data. In this video, I'm going to cover importing data for and creating a topographic surface, as well as importing and draping a map or image on that topography. To begin, I will create a new project. When it comes to introducing data into that new project, a topography is a good place to start. There are a number of different data types you can use to create a topography surface within Leapfrog. As you would expect, the Topographies folder is where a surface representing topography is created. The functionality of that folder is accessed through a right click. If I select New Topography, I can see my options available. Some file types, such as elevation grids, can be imported directly into the folder, while others need to be imported into their relevant folder before being used to create a surface in the Topographies folder. If you don't have an actual topography surface, but would like something to constrain your models, there is an option to set a fixed elevation. Topography surfaces built as an elevation grid will be static, while topo surfaces built from the surface GIS vector data or points options are fully dynamic, which means if the dataset or surface is updated within the project, the topography surface will also be updated. In this tutorial, I will import an elevation grid. Creating a topographic surface from other data types will be covered in subsequent tutorials. I'll select the correct file for my elevation grid and click Open. When an elevation grid is imported, you are given the chance to set the resolution, as well as decide what to do with areas of no data. The resolution in Leapfrog defines the physical size of the triangle making up the surface. In this case, the resolution is 50, meaning the triangles are 50 units across. Which units depends on what you have imported. Leapfrog is a unitless program and therefore takes on whatever is introduced. If the data imported is in meters, then the numbers throughout Leapfrog will be in meters. If the data is in feet, then the numbers are feet. In this example, our units are meters, so the resolution on the topography is a 50-meter triangle. If you would like a finer resolution to define a more detailed surface, you can lower the value to make smaller triangles. Conversely, if you have a simple surface that covers a very large area, you can increase the resolution value to make larger triangles. The concept of resolution will be discussed in more depth in a different tutorial. In this case, where I have no data, I'm going to simply ask Leapfrog to leave a gap and select Import. I will leave the name Topography and click OK, and Leapfrog will generate the topography surface. Now that we have a topography surface, let's look at importing maps or images and draping them on the surface. In this session, I'll demonstrate importing both georeferenced and non-georeferenced images. Importing a georeferenced map or image into Leapfrog is a very simple process. The most important thing to ensure is that the georeferenced data is in the same coordinate system as the rest of the project data. All 2D data in the XY plane is imported in the GIS Data, Maps, and Photos folder. To import a map or image, simply right-click and select Import Map. The Import Map option will allow you to import any image file in the XY plane. In this case, I will select the GeoTIFF option. If you import a GeoTIFF, you are importing the image as well as the georeferenced data. There is an option to override the existing georeferenced data if necessary. However, I will accept the coordinates and click OK. As you can see, it was very simple to import that georeferenced image. Now let's look at importing a couple of non-referenced images, and you'll see that that process is also quite straightforward. There are 2 methods available for registering a non-referenced image. The first one is to manually place these markers as far from each other as possible, and then enter the corresponding values. So I will do that now. I placed the marker by simply clicking on the marker box, and it will place the marker near the center of the image. I can then simply pick it up with the mouse and drag it to a coordinate. I zoom in and out in the image by using the scroll wheel on the mouse, and I can pan around the image by simply clicking and holding the left mouse button. Once I place a point, I can simply enter the respective coordinates. You'll notice when I enter a value, a reference line shows up in the main scene. When I enter the corresponding northing, it then places that point in the scene. Once I've selected those 3 points, I can simply click OK. There is a second method that can be used if there are no coordinates on the map, but there are identifiable areas in the topography. In that case, we can use registration markers to georeference this image. I will arrange my screen such that I can see my topography on one side and the image I wish to register on the other. I'll activate the marker as I did before by selecting the marker and then moving it to an identifiable place on the image. In this case, we can see there is the narrow point at the end of the lake in the image, and we can also see that narrow point at the end of the lake in our topography surface. By selecting this icon, I can click on the scene to place a registration mark, and it will populate the coordinates accordingly. Another distinct feature is this spit. Again, I will select the registration mark to click that location on the topography. Once I've selected all 3 points, I can simply click OK. Now all the images are imported, let's see how they're draped on topography. You'll notice right now the loaded topography shows up in the scene, but it's actually sitting at 0 elevation, below our actual topography surface. These image files themselves are not actually that useful, so I'm going to select them in the scene list below by double-clicking on one of them and remove them from the scene. You'll notice this loaded topography surface shows up in the scene list below as well. Below the topography surface itself is a GIS Select drop-down. This selection is broken up into different types of 2D data for better organization when you have a long list of imported items. If I select the Maps and Photos option, I'll see I have 3 images. If I select one of those images, it will drape it on topography. If your original image had covered the entire area, then this would be sufficient, but in our case, the image was broken into 3 pieces. Fortunately, Leapfrog has a way of adding multiple objects or layers to a topography surface. This is done by creating a view. From here I can select Edit Views and create a new view. I can now select all 3 available layers and add them to my topography surface. Once I've added all of my layers, I can simply click Close. If I'm happy with the way the image is registered, I can leave it. However, if I'd like to edit any of the registration, I can simply double-click that item in the project tree, and it will reopen my registration options. In the next video, we'll take a look at importing GIS data and 2D grids and viewing them on the topography surface as well.